This is GATE 2014 set 2 electrical question number 30. The voltage across the capacitor as shown in the figure is expressed as Vc of t equal to A1 sin omega 1 t minus theta 1 plus A2 sin omega 2 t plus theta 2. This is the circuit given. Then the values of A1 and A2 respectively are being asked. For NPTEL reference, you can refer lecture Superposition Theorem of the NPTEL course Basic Electrical Circuits by Professor Nagendra Krishna Pura, Department of Electrical Engineering, IIT Madras. For useful data, you can see that for a linear active bilateral network, the response across each element is the sum of individual responses of each active independent sources with other sources replaced by their internal resistance. So that means that if there are more than one sources, that is active independent sources, so if you want to find the response across some elements, such for example for across a resistor you want to find the current, then that current will be a sum of contribution due to one source and similarly due to another source and likewise. So all the contributions of this source taken independently by deactivating the other sources, that is by replacing them with their internal resistance and deactivating them, considering only the contribution of that particular source. If you sum like that, then the sum of the individual responses of each of those active sources will give the net response across this element. So one thing also you remember, that while deactivating a source, you replace them with their internal impedances, and for ideal voltage source you replace them with their internal impedance, that is 0, and for ideal current source the internal impedance is infinity. Coming to the solution, step 1, you deactivate this current source, so replace it with its internal resistance, that is infinity, so open circuit. So this is gone, this branch is gone because this is open circuit. So now we have like this, and this is the capacitor of 1 farad and this is 1 ohm. This is 20 sin 10t. Now this is Vc1 of t, that is for the first source we consider the voltage across the capacitor. This can be found out by voltage division rule. So this is 20 sin 10t into, so this is 1 by j omega c, where c is 1, so 1 by j omega divided by 1 by j omega plus 1. So actually this can be written as 20 sin 10t by 1 plus j omega, we can write that. Now taking it in its phasor form, that is 1 divided by 1 plus j omega. Now omega is 10 as you see from here, so 20 sin 10t divided by modulus of this, which is 1 square plus 10 square, into, and the angle tan inverse 10, which if you take above in the numerator, then it will be minus tan inverse 10. So this is the response which is coming out as 20 by root 101 sin 10t minus tan inverse 10. Similarly for step 2, we find out Vc2 by deactivating this source. So this is short circuited and this is Vc2, and here we take the inductor 1 Henry, and this is 10 sin 5t. So now omega becomes 5, so this is actually 5 into 1, so 5 ohm, j5 actually, and this is 1 by j5 into c, which is c is 1. Vc2 of t is 10. Now considering sine of something, so this is 0, so 10 angle 0. So this is current division rule now, into 1 divided by 1 by j5 plus 1, that is current in this branch is the impedance in other branch divided by net impedance in the two branches, then we get the current in this branch. So we are actually getting 10 divided by 1 minus j.2, which is coming out to be, so 10 angle 0. Now we can write 10 by root over 1 square plus 0.2 square, and now sine of 5t minus tan inverse minus 0.2 divided by 1. So this is coming out as 1.98 sine 5t minus theta 2. Let this be theta 2. So now a2, this is a2 and this is a1. So this is a1. So 20 by root 101 is coming out as 2. So now a1 is 2, a2 is 1.98. Option A is the correct option.